With environment values, we're ready to finally extend our interpreter. So here's one example if we're interpreting a let expression, starting off here in the empty environment and an empty list of function definitions. After the first step, we should extend our environment with the binding x equals to 1. Then after the second step, we extend the environment again. Now we have y equals 2, x equals 1. And from then we go to evaluate the addition inside. And when we finally see a symbol inside the body, that's when we'll look up inside our environment and we'll see that y is equal to 2. Here's our interpreter function, and we have 3 blank spaces to fill in. First for the identifier case, then for applications, and finally for let. Identifiers first. If we see a symbol, we need to look that up in the environment and return the value. Now for let. And to help guide us through, we have an example here. Let x equals 1 plus 2, x times x. So n refers to the first x here. The right-hand side is 1 plus 2, and the body is the multiplication, x times x. So the first thing to do to interpret this let is to interpret the right-hand side. We can do that interpretation with the same environment and definitions that we had as input. Once we've got that value, so referring to the example, once we know what the result of 1 plus 2 is, we want to bind that to the symbol x. So we create a binding, and we use that to extend our environment. And now with that extended environment, we're ready to interpret the body. So the environment here is acting just like an accumulator. We're building that up as we evaluate the expression. Now for applications. So suppose we have an application f called with 1 plus 2, and then we have a function definition that says f multiplies its input. So the first step of evaluating the application is to look up the function definition symbol, and we use our list defs for that. And now we need to decide what to do to figure out what the result of the application is. So first things first, we definitely want to interpret the argument relative to the current environment and definitions. And then once we have that value, we want to bind it to the symbol that the function uses for its argument, and then use that to interpret the body. There's one question here though. What environment do we use for the function body? So let's jump to an example. Suppose we have a bad function here. Bad takes an input x and adds x plus y. And the reason it's bad is that this y is a free variable. But now suppose we had that function in our definitions and we called the interpreter on an expression that says let y equals 2 and then bad of 10. Well, our interpreter would start off with the empty environment, and then when it sees y equals 2, it would add that binding. And then if we were to use that environment to evaluate the function body, we would suddenly see, oh, y is no longer a free variable. Y is bound to 2. So we get the result of whatever x is plus that 2. This is not what we want. We should get an error. And in order to reach that, we want to make sure that when we start interpreting the function body, we only have one substitution, and that's the one that's for x, the function argument. So back to our interp function, we don't want to use the environment going in for the application. Instead, we use the empty environment. So to interpret the function body, first evaluate the function argument, extend an empty environment with that, and now finally interpret the function body.